Chapter 3.1, Extrema on an interval, day 3. We're going to do some more practice problems with extrema on an interval. No new information on this topic today. Day 3. So find the extrema of h of x equals sine squared of x plus cosine of x on the interval from 0 to 2 pi. First off, make sure the extreme value theorem does in fact apply. Sine and cosine, are those continuous on the closed interval from 0 to 2 pi? Yes, they're continuous. This isn't a closed interval, so we're going to have to just be careful at the right side. All right? So extreme value theorem does not apply, but I'm going to put that there so we can evaluate the rest of it. And then we'll just have to throw that part out if it happens to be a max. All right, so first step after we make sure it applies is to find our derivative. H prime of x equals 2 sine x, and using the chain rule we need to take the derivative of what's inside the square. It will be 2 sine x cosine of x minus the derivative of cosine, or plus the derivative of cosine, which is negative sine x. We'll set that equal to 0. I'm going to factor while I do that, so it'll be sine x times 2 cosine x minus 1. So I'll use the zero product property. Either sine x equals 0 or 2 cosine x minus 1 equals 0. In this case, cosine x equals 1/2. All right, where does sine equal to 0 on the interval from 0 to 2 pi? Well, that's x equals 0, x equals pi, x equals 2 pi. Let's just be careful here. Let's put a little warning face there. All right, where does cosine equal 1/2 in the interval from 0 to 2 pi? Well, cosine equals 1/2 at pi over 3, and in the fourth quadrant at 5 pi over 3. So what we need to do is we need to check our endpoints and our critical numbers. Now, 2 of our critical numbers happen to be our endpoints, so that takes care of some of it for us. So we need to do h of 0, h of pi, h of 2 pi, h of pi over 3, and h of 5 pi over 3. Now in calculus, everything is in radians, so let's just go make sure our mode is radians. Hit the mode button. Make sure you're in radians. We are. Go to y equals, and we'll type in our function. We got the sine squared of x. To enter that into the 84, you go sine x, close your parenthesis, and then square it. Not standard form for it, but it works. Plus cosine x. And we'll go and take a look at our table. Okay, our 5 numbers are 0, pi, and this will show up as 3.14, 2 pi, pi over 3, and 5 pi over 3. Okay, as we take a look at those, we can see we have a maximum, and it occurs twice. Our maximum is 1 1/4, and it occurs twice at pi over 3 and 5 pi over 3. And our minimum is -1 and occurs at pi. And our value at 2 pi is not an issue, so it's not. We don't need to worry about it not being a max or min. We can kind of double check this graphically. Our window goes from 0 to 2 pi. And our minimum is -1. And our maximum is 1.25. We should see the entire graph if we did this correctly. And there we go. And we can see we would have an open circle here and a closed circle there because of the interval they gave us. We'll put that interval back now. All right, let's look at our next problem. H of s is 1 over s minus 2 on the interval from 0 to 1. Again, make sure it's continuous. There's a discontinuity at 2 here. However, our interval does not include 2, so it is okay. And we have a discontinuity, but it's not on our interval, so we don't need to worry about it. So we will find our derivative. I don't like s as a variable because my s's all look like 5s. So I'm going to change that so it's x. So you can kind of see what I'm doing and not think I'm doing 5 minus 2. Why don't I simplify that to 3? All right, so I'll find my derivative, h of x. We'll do the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all over bottom squared. All right, this is a 0, so that'll just kind of cancel off. We got h prime of x equals 1 over x minus 2 squared. Where is that? 0 or undefined. It's a fraction, so it's 0 and the top is 0, which we can see is not happening because 1 will never be 0. It is undefined when the bottom is 0, and the bottom is 0 when x is 2. However, 2 is not in our interval, so we can ignore it. All right, so finish this problem. We'll check our critical numbers, of which we have none, and our endpoints, 0 and 1. And we can find our extrema that way. So we will graph our function, 1 over x minus 2. And we'll check our endpoints, 0 and 1. We got 0 there. We got 1 there. And let's clear the rest of these out so it looks halfway decent. There we go. And we can see we have a maximum of -1 when x is 1 and a minimum of 0.5 when x is 0. Power. Let's apply it now. The formula for the power output of a battery is P equals VI minus RI squared, where V is electromotive force in volts, R is resistance, and I is current. Find the current, measured in amps, that correspond to a maximum value of P in a battery for which V equals 12, R equals 0.5. Assume that there's a 0.5 fuse bound output in the interval 0 to 15. Could the power output be increased by replacing the 15 amp fuse with a 20 amp fuse? Explain. First off, plug in our constants. V is a constant 12, R is a constant 0.5. So our equation ends up being P equals 12I minus 0.5 I squared. All right? Now the 15 amp fuse, that is my interval, and it is a closed interval, so I can find my max and min for 0 to 15. And I'm going to do that by taking the derivative, 12 minus I, and seeing what makes that 0. And that is 0 when I equals 12. So my critical number here is I equals 12. So I need to use my endpoints, P of 0, P of 12, and P of 15 to see what my maximum power is. All right, so go back. My function here now is 12i minus 0.5i squared. And I need to check my critical numbers and my endpoints. 0, 12, and 15. All right, so here my max power is 72. Can I increase power by increasing my interval from 0 to 15? All right. Oh, I'm sorry, from 0 to 20. What that means is we need to do the same problem over again. This time, my interval is from 0 to 20. Well, the critical number is not going to change. All that's going to change is my endpoints. So here I need to check 0, 12, and 20 and see what my power is. All right? So the only thing that's going to change is that last interval. And did I increase power by increasing the amp? And the answer is no. My maximum power stayed the same. The maximum is still 72, and it's still at 12. So no, I did not increase the max. The max is still 72. So in conclusion, to find the extrema, you must verify you have continuity on a closed interval. You're going to find your derivative and use that to find the critical numbers. And the critical numbers, f prime of x equals 0, or f prime of x is undefined. And that's to account for the cusps. And then check the critical numbers and the endpoints on the interval. The highest value there is your max, and the lowest value there is your min.